So yesterday we started with the data frame transformations. So we'll continue from there. And today we'll understand more detailed level transformations, mainly related to data. So how we can remove null data, how we can remove duplicate data, and then other transformations like select expression, filter, group by, order by, group functions, and then a repartition and coalesce. So when we will use this. Then we'll start with the delta. Okay. But in a way, first we'll finish all these transformations. Then we'll understand write API. So our focus is to understand extract data and apply transformations, then load the data. So when we are when it comes to any data engineering project, like wherever we use a Pyspark, like wherever we have a lakehouse implementation, so extraction, transformation, loading. So we'll use a read API, that is extraction. We'll create a data frame. Then we can apply transformations. Then we can use a write API. So that is loading. So the target always when it comes to lakehouse, we'll use delta table. Target always will use a delta table. The source may be any format, because when it comes to files, landing always the landing. That may be a files, may be a table. But when it comes to files, any file. So it may be any delimiter or any other formats, CSV or TSV, any other delimiter, or Parquet file, or ORC file, or Avro file. Okay. So source may be any format, but always the read API. Read API supports all the formats. Then we'll apply transformation. Then we'll load the data into target. The target is always a delta table. Target is always a delta table. So here we can go and create a data frame. So we just started with a CSV file. Let me clear the cell output. Okay. So here we are able to read the files. So we created a data file here. And the data file where we created a data frame. We created a data frame. Then we used a schema. So we created a schema, Pyspark schema. Then we created a data frame. Then we applied the transformations. Just we'll revise all the transformations which we covered yesterday. Then we'll move on, understanding remaining transformations. So yesterday what we did, we covered metadata related transformations, where we can add a column using a with column. That column may be a static value or that runtime value. Static value means we can use a let function. With column, we can use for adding a column. Two arguments which will allow. The first argument should be a column name, and the second, it's a string. Column name should be a string. The second argument should be a function or expression, function or expression. So we used a function. The let is a function where we can use a static value or a runtime value. Runtime means we can use a functions, current timestamp. Similarly, same with the column we use for changing data type. So existing column name, then toDate is the function we use that. Same with the column we can use for any expressions also. Any expressions also. Drop for removing columns, comma separated, we can specify a number of columns. And with the column renamed, we can use for renaming old column name and then new column name. It will rename a column. Then if you want to rename all the columns, we can use toDF. toDF for all the columns and select for selecting the required columns. If your data frame is having more columns, if you don't need all the columns, one option you can remove drop, or another option is use a select. Okay. If you want to select a few columns, use a select. If you want to select more columns and remove only a few columns, then use a drop. Okay, both are same. A drop and select both are same. Okay. Anyway, it is not going to remove from the existing data frame because data frame is immutable. Always it will return a new data frame. Data frame is immutable. So it will return a new data frame, and the existing data frame always will be there, and the new data frame also we can create. But anyway, data frame is just a metadata operation. It doesn't store any data. You can create n number of data frames. Just a metadata operation, doesn't store any data. Only the data will come into the picture whenever we use an action. That action may be a displaying data. That action may be a saving data. So saving data will understand the write API. First we'll understand the transformations. So first we'll finish all the transformations. Then we'll understand write API as well. So write API available options. That also will understand. So yesterday we applied these transformations. Then displaying the data. So display is a function where it will display the data and the final, okay, and the final output. Now, so today what we'll do, we'll understand other transformations, data related transformations. Like removing null rows, removing duplicate rows, filtering data, selecting required columns with the expression. This is very important. Select expression is very important. If you understand the SQL, so entire SQL operations which you can achieve through the select expression, that also will say that. Similarly, group by, order by, joins, others also will see that. So let me display that original data frame. The original data frame which we created. It is having some null data, it is data, and it different type. Okay. You see, we have a duplicate data, null data here. So how to remove null records? Null records, if the entire row is null or if any one column is null. Consider if the entire row is null, then if you want to remove, then remove. Or if one column is null, if you don't want to remove entire row, then just ignore that. So if you want to remove entire row, even one column is null, then that is also possible. So that will understand the transformations. That will understand this transformation. Give me a second. Just I'll mute. I have to attend one call. Give me a few seconds. Okay. So let's resume the session. Sorry for that. Where we can understand the transformations. Like if you want to remove null rows here, like we see few columns are having null. Okay. Our entire columns are having null. Normally we want to remove if one column is having a null. That is possible because some columns, if that the columns don't have data, doesn't mean that we don't need to remove that entire row. If all are null, then we can go and remove. So how to remove null rows? So let's apply a the drop NA. The drop NA is transformation, and the default value, there's a parameter called how. The default value is any. Default value is any. We even you don't need to give that. I'll show you that what is that exactly. I'll show you the data as well. Now, if you look at this, only 8 records are there. Now it is removed almost all the records out of 33. Out of 33. So it's removed 25 rows. And only we can see the 8 rows. Why it is removed all those records? So if any column is null, if all columns also is having null, it will remove that entire row. So let's verify here. Sort this. Now it is removed this record. It is removed this all the records because this is having a null, and it is removed this record as well. It is having a null, and this is removed this record as well because it is having a null. So that's why we see only out of 33, 8 records. Wherever null is there, like this entire row is all the rows is removed. So all the rows it's removed. What will happen whenever we use a drop NA? Drop NA is going to remove null records if any one column is there. That's the parameter called how equal to any. That is the default value. Even if you're not specifying, this is the default value. Any means if any column is having a null, it will remove that row. If any column is having a null. But normally we should not remove if any column is having a null. Remove only all columns. Just keep the value as all. Now what will happen here? Like if you go and verify here, commission is having a null. Still the record is not removed. But only it will remove if all columns are null. Only out of 33, 3 rows are nulls. Then only the 3 rows it's removed. So the drop NA, if you're not using any parameter, the default it will consider as how equal to any. Even if you go and verify the syntax, so this default the how parameter is any. Okay, so what will happen if you're not giving any argument? The default it will consider as any column, any, then it will remove any column is having a null. So if you want to go with that, if any one column is having a null, if you want to remove that row, we can decide that. But normally we won't do that. We won't remove that entire row if one column is null. We'll remove only if all columns are null. Or specific columns also we can consider. That's called, which we can use another argument. Okay, so which we can go and use a subset, which is set of columns also which we can specify. That you can specify a tuple, you can specify a string, you can specify the list also. But the default that value will be none. None means if you're not specifying that, it won't consider that third argument. So if you want to go with a specific, so you can use a subset. The subset which you can give us a string. Consider now you see here, we not used the first argument, but we used a subset. Subset means if this column is null, then remove only those records. But other columns are having null. Now you see here hire date is null. It is not removed. So normally when we will use a subset, any primary column, like this is a subject date, right? Employee subject. Employee number is the key column. So even you can go and remove a primary key column based any employee number is null, go and remove that row. That's all. Now only the 3 rows are null, then it is removed. The subset when we will use, if you know that the data set is having a primary key column, then specify that primary column, or maybe 1 or 2 columns. Even you can go and use tuple or list also you can give. It will allow tuple or list also it will allow. So when we will use this subset, if you know that the data set is having one column, that column basis if you want to remove null, like normally when we will decide that subject data, consider you have a customer ID, product ID, okay, location ID. So every subject that will have a subject ID. Those column also you can use. Like here we are using employee number or employee ID. Okay, employee number or employee ID. So that basis you can remove duplicates. Sorry, null records. This is for drop NA. Drop NA for removing null rows. But here we see some null rows for other columns, right? Those you can convert null values to actual value. But before that, I want to remove duplicates. So how to remove duplicates? I'll create another data frame from df2. So there's a transformation called drop duplicates or drop underscore duplicates. Both are same, it's alias name. Okay, both are same. For removing duplicates, you can use df dot drop duplicates or drop underscore duplicate. Both are same, just another name. Okay. alias name. It's also same. This also, there is no difference. There are some functions, alias functions. Alias functions means they'll have two names, but the concept will be same. Okay. So we can use a drop duplicates or drop underscore duplicates. Both are same. Okay. So here, default all combination, all the column combination, it will remove duplicates. So consider we have a 30 rows, right? We see the 30 rows are available. Now, if you go and verify all column combination, we don't have any duplicates actually. All column combination, we don't have a duplicates. Okay. But I want to remove duplicates based on the primary key column. Primary key column means like we can give an array here, list, employee number basis. Remove duplicates if any employee number is repeated. Out of 30, 50 rows are duplicates, it's removed 50 rows. But in that, if you want to keep the latest one, remove the old one. Then you have to do that sorting mechanism. I'll show you that. Let's take Miller as example here, 7934. And that updated date is January 3rd. Let's go and verify here, sort this. Here is the Miller record, okay? In that, everything is same except this updated date. Consider maybe a salary is different. But we removed based on employee number. The latest record is having a different salary, the old record is having a different salary, consider. Then how you will remove that? How to identify the latest one? Then keep the latest one. How to identify the latest one? Keep the latest one. So what we can do? We can do the sorting. So sorting whenever you do on the updated column, then descending order. So whenever we see here, it will keep this row. Any repeated is the next row it will remove. But if we do the descending order, then this record will come into the first. This record will go to the next. We can use order by. So order by is another transformation. You can specify the column name. Okay. So here the updated date. Then you can give a second argument ascending. So false. One option is, I'll show you the syntax also. If you want to know any transformation in the syntax, remember, use a help function or go to the documentation. So going through the documentation always is very difficult, right? So, but the first time when you're learning, better to refer the documentation. The same documentation comes here also with the help. Okay, same documentation. Now you see here, order by or sort, both are alias. It will give you that alias also. Okay, sort or order by, both are same. Sort by is not, sort by is different again. Order by or sort, both are same, just alias name. Always remember this. df dot order by or df dot sort, not sort by. Sort by is a separate transformation is there. That is different. Sort, order by, both are same, just alias name. Okay. So similarly, filter or both are same. Similarly, drop duplicates or drop underscore. Group by. So here totally a different spelling. You see here, this is order by, this is sort. This is also different word, filter and where. This also same word but just underscore. And this also same word, just a case sensitive. That's the only difference. This is case sensitive difference. Alias name, another name. This is naming convention, camel case, Pascal case. This is underscore. This is a camel case. Just this is totally word itself, it's different word. Okay, these are alias names, we'll call it as alias names, another names. Similarly, you can use a sort or order by, both are same. No difference. Sort by is different. Sort is different. Sort by is available in SQL, Spark SQL, not in Pyspark. This is a Pyspark. Sort or order by. Okay. Even when go and verify the documentation, same information which you can find this same information. So we can give a columns. Okay, we can give a columns as a string, as a list also we can give. Okay, columns you can give a string, one column, or a list also we can give. So ascending, descending functions are available. You can go and import those functions you can use, but default is ascending. Explicitly, you don't need to use ascending, but default is ascending. Okay. There are two functions are available. DESC means descending, ASC means ascending. Those functions are available. Explicitly go and use those functions. Or even default is ascending, then descending, you can give another way also. I think the syntax here. Ascending false if you use, that would be a descending. This is one option, another option. Both are same. Technically, both are same, but the syntax is totally a different syntax. So just I want to explain this. Even you can use ascending false means it will do the descending order. Okay, now you see the descending order. Or if I go and use a function called DESC. So this, if you use a call function, because default it is a string, right? A string does not have that function. So if you use the call function, then use this DESC. This is another method to give a descending order. Okay, both are same. So this is one method, because two syntaxes are there. Don't get confused on that. It's also same. Ascending equal to false. This is also same. Okay. Or even you can import the function. You can directly use a DESC function here. DESC. But that function we explicitly we need to import. Okay. So this function is available on top of this column, call function. Okay. But this is a separate function. Explicitly you need to import and use this. All are same, just a small difference in the usage. Or you can use sort also. Okay. Just alias name, sort and order by, both are same. So there is a difference in Pyspark, order by or sort. Okay. Both same. In Spark SQL, order by and sort by, both are different. Sort by, order by, both are different in Spark SQL, because it's not a sort by, the order by. This is both are different. Sort by is equal to sort within a partitions. Sort within partitions. So in Pyspark also we have a function called sort within a partitions. Sort within a partition. So partitions wise it will do the sorting, not a global sorting. Okay, this is a different. This is the same as in SQL sort by. Okay. Sort by in Pyspark, Spark SQL is same as like sort within a partitions in Pyspark. Pyspark sort within partitions is same as sort by in Spark SQL. Okay. So remember this. Sort within a partition is equal to sort by in Spark SQL. But order by, both order by and in SQL, order by in Pyspark, both are same. But only Pyspark we have alias name is sort. Sort, order by, both are same in Pyspark. There is no sort in a Spark SQL. Sort by is available. Sort by is the same as like sort within a partition. So this is sort by is a local partitioning. Sort by local partitioning. Sorry, local sorting. Local sorting means partition wise sorting will happen. Similarly, when it comes to order by or sort, is global sorting. Global sorting. Entire data set may be a table or a data frame, level sorting. So now you see this entire data set level sorting, data set level. But if you have multiple partitions in the backend, so the partition wise you want to sort, then you have to use sort within the partitions. But anyway, this is smaller data set, only one partition is there. If you have one partition, both will be same. If we have only one partition data, then order by or sort within a partition will be same. There is no difference because if you have only one partition, local partitioning, global sorting will be same. That's why this data set is only one partition, small data set. So that's why you don't see, even if you use a sort within a partition, even if you use order by, both are same. Only the difference will come into the picture if you have a huge data. If you have multiple partition, then sort within a partition will do partition wise a sorting. Order by will do table partitioning. So sort within a partitioning is required only whenever you use a joins and the bigger tables. Use this. If you're not using a joins, then use the order by. Okay, whenever you use the join, use sort within the partitions. Order by, just use a global partition. Global sorting. So, like here, if you want to remove duplicates, but keep the latest one first, then before that you need to do the sorting. So I'll do the order by here. Order by or sort, both are same. Okay, you can use any one. Column as created date, descending order. Okay, this is one method. Then now if you go and verify the Miller, latest record which you can see, old record it is demo. The January 3rd record is removed, January 7th it is keeping. Okay. Duplicates only it's removed, but it's kept the latest one. How it is keeping the latest one? Because we did the sorting mechanism, descending order. So descending order can be done directly, descending function or on column level function. Column level function also you can do, or descending separate function is available, or you can do this comma ascending equal to false. All are same, just different ways to do this order by. Sort also. Okay. So sort or order by both are same. Now how many transformations? A drop and a removing duplicates, a sort or order by sorting the data, drop duplicates for removing the data. So why we are doing a sorting before dropping duplicates? To keep that latest data first, then remove older records. That's why we are doing a sorting here. Now we remove duplicates, then converting null values to actual value. Converting null values to actual value. In number of data frames, there is no issues because every data frame is just a metadata. Even better to have multiple data frames whenever you are applying a multiple transformations, you'll have a more lineage when you walk through the code. Okay. Then fill NA. Fill NA is a transformation where you can fill the values. Fill NA is another transformations. It will allow multiple ways to give the input value. We can give a JSON dictionary. Okay. This is a list. This is a string. This is also string. Similarly, fill NA will give you directly as a value string or number or even JSON dictionary. So what is JSON dictionary? Key value pair. So consider wherever commission is null is there, I want to fill the 0. Okay. So we can go and directly use key value pair like this. column name, wherever commission is there, go and fill with the 0. Fill a name. Okay. Or without, if you're not giving any column directly, if you give the value, right? Wherever integer columns are there, it will fill the 0. Wherever integer columns are there. Now MGR is integer column, manager ID. Commission is integer column. So wherever integer columns are there, it's filled with the 0. Okay. Or if you give any string value, wherever string values are there, then it will fill that. Wherever string values are there. So commission is not a string. MGR is not a string, but this is a string column. It is filled with n by n. Okay. So blindly don't go with this fill n with directly a string or integer. Go with the column specific. Go with the column specific. Column specific it is. Boss, wherever commission, give the column name as a double quotes. Okay. The dictionary, Python dictionary, he always should be a double quotes. Okay. Can't give as a value, you have to give as a double quotes as a string. He always should be a double quotes. So wherever MGR manager ID is there, fill like a double line, double any number. Just I'm giving to show you that each column wise it will count. So wherever hire date is there, go and fill this 31st December 1999. Now if you verify here, wherever is null is there, it filled a double line. Wherever null is there, filled a 0. Wherever null is there here, filled with the calendar end date. This is calendar end date. Okay. Fill NA for converting null values to actual values. So this is the syntax dictionary. This is a dictionary. That's why Python is very important when it comes to Pyspark. So let me explain you. Markdown, core Python. So the core Python, when you look at the core Python, right? The first one is variables. You should understand the variables like integer, string, boolean, all these variables. Then collections. The collections, we have different types of collections. One is list. Anything in a square bracket, that will be a list. Then tuple. Anything in a curly brackets, that will be in a tuple. And the sets with key value pair, that is a sets. Key value pair, that is a dictionary. These are our collections which you should know. Those collections only we are going to use here. That's why you see here the string double quotes and the integer 0, double line. Then that list square brackets, dictionary open and close with the curly brackets. The sets and dictionary difference here, it is key value. Okay. That's the only difference between sets and dictionary. Sets you can have a direct value. Sets won't allow duplicates. List will allow duplicates. List will allow all the data types. Tuple is immutable. So every data type is having a own nature. A list will allow everything. It will allow duplicates. List is mutable. Mutable means you can add, you can remove, you can delete. Okay. Tuple is immutable. Okay. Sets won't allow duplicates. Dictionary key value pair. That's why we have 4 types of collections. Then for loop. Loops, we have a for loop or while loop. So without this, there is no Pyspark. Without these concepts, there is no Pyspark. So everywhere we are going to use that strings, dictionary, okay. Collections like a list, tuple. The syntax is also going to go and verify the syntaxes here. You see, column names we are giving a list. And even when I go for drop and it will allow multiple data types. Boolean data type, list data type. String data type, list data type. Okay. So this is about few things. Now fill and where we can use a dictionary. The argument it will allow dictionary or individual value. So if you want to know that, what it will allow that, just go and verify the documentation. Markdown for the documentation. Use a help. Will give you the syntax. Integer, float, string, bool, or dictionary. This is individual values you can give values. I just integer, float, string, bool, or you can give a dictionary. Dictionary means key value pair. Okay. The dictionary always will go and replace the values. And even you can give a subset. Subset when you will use whenever you go for integer or individual values. Set of columns also you can give. Anyway, dictionary already we are giving a set of columns. Set of columns. So we already gave the set of columns. NA dot fill and name. Both are same, just alias name. NA dot fill or fill and name. Both are same. Just alias name. Fill and name is a direct. Drop and NA dot. Both are same. Okay. Alias NA dot drop. Drop and name. These are our alias names. Okay. So I just typed here all the alias names. You can just keep that in information. Df dot NA dot drop or drop NA. Both are same. Alias name. Fill NA. You can say NA dot fill or both are same. Just another name. Okay. Another name. Alias name. NA dot drop or drop NA. NA dot fill NA. Both are same. So now what? Just revise list of transformations which we covered. Maybe let's verify here. Removing null records, removing duplicates records. Okay. And converting null values to actual value, fill NA. Then sort by, nothing but sort or order by, covered. Then we have a filter, select expression, repartition, those also is there. Okay. Just before going to other transformations, just I'll give some time if anyone is having any questions. We covered this. Then we covered this. Dot. NA dot drop. So we covered these transformations. Removing null records, removing duplicates records, converting null values to actual value, and thus sorting the data, sorting or ordering the data. Then filter, select expression, group by, we'll see this. Then joins, also their joins, set operators, that we'll see tomorrow, okay? But before that, I'll just pause here. If anyone is having any questions on this, you can ask me now. Any questions? Hope it's clear. Any confusion?
Oh.
If you have any confusion, just you can ask me, I'll explain it, okay?
No, it's clear.
Thank you. Others? These transformations are very important. So normally when you go to write any project, without these transformation, there is no project. Whatever we covered yesterday, whatever we are covered today, we are going to cover today and tomorrow. This everything 100% which you are going to use in the project, which you can expect part of the interviews. Just 90% the job will be done on these transformations only. That also you can expect every piece of topic part of the interview also. Syntax and using those transformations also is very important. Practically, you should go and apply on the data frame. Then you will have more clarity how it is applying. After applying, how it is returning the data. That also you will have more clarity on this. Okay. If we don't have any queries, then we'll continue on this. Hope you guys are good. Then we'll move on next. So let's understand. Select expression, and then group by aggregate functions, group functions or aggregate functions. Okay, group functions or aggregate functions. Then tomorrow we'll go and understand the joins. Then I'll differentiate. I'll give a difference between in that all the transformations. Some are simple transformations, some are complex transformations. Those we will call it as narrow transformation and the wide transformations. This is knowledge purpose only. Everything is a transformation only. Whatever you are going to use a filter, select, drop, with the column renamed. Okay. Similarly, drop and a distinct, drop duplicates, order by, group by, joins, cross join, repartition, right? Technically, everything is transformation, but functionally, we are divided them into two parts. Actions are two parts. Transformations are two parts. Actions are two part. Transformations are two part. Action displaying data is an action, saving data an action. Similarly, transformations are two part. How we are saying that those transformations are two part? Narrow and wide. But how you will tell that which one is narrow, which one is wide? If any transformation is doing a shuffling, two stages, that is wide transformation. If any transformation is going a single stage, no shuffling, that is narrow transformation. I'll repeat. If any transformation is doing a without shuffling, that is single stage, narrow. If any transformation is going with a two stage, with the shuffling, that is wide. So I'll show you this difference, then we'll see that, okay? Then anyway, tomorrow also we'll understand the filters. With joins also is there, wide transformations, repartition, that also will understand. Okay. Repartition collision, that is very important for interview point of view. Mainly 100% every interview they'll ask you difference between collision and repartition. This one and this one. Why they'll ask you in every interview? Mean to understand, are you having a clear picture on that? Do you have a knowledge on the types of transformations? How you will differentiate which one is narrow, which one is my wide transformation, and what is shuffling? So those concepts purpose only they'll ask these two transformations. Their intention is not to give you on what is collision, what is repartition. Their intention is, do we have a deep knowledge on what is shuffling, and what is narrow and what is wide? Okay, narrow transformation and wide. That's a primary focus of when someone asks you the difference between collision and the repartition. Do you have a clear picture on what is shuffling, what is no shuffling? Okay, let me show you that. First, we'll show you with the drop duplicates. Then you will have some more clarity on that. Okay. Anyway, tomorrow also we'll discuss that. So I'll create a data frame. I'll apply select. What is select? Select is for selecting the required columns. Okay, select is for selecting required columns. I'll select a few columns: employee number, employee name, salary, department. Just I'm filtering, selecting columns, filtering columns, filtering columns. Then I'll create another data frame. I'll use a filter. Filter or where? This is for filtering rows. Instead, I'll filter only department number equal to 10. This is for filtering rows. Filter or where, both are same. df.filter or df.where, both are same. There's no difference. Both are same, just alias name. Okay. Now it's two data frames it's created, right? Now, when we apply this transformation, it's created another data frame. Let's verify this data frame. Whenever we are applying this transformation, is the transformation is narrow or wide? So how to differentiate that? Go and use a display. Use a display. Action. When you use action, then you will see the data. Whenever we see the data, if you go and verify this job, you see only one task is executed. One task. How it will decide? One task is always depends on the size of the data, means number of partition. Similarly, one stage is executed. So how it will decide one stage? The one stage it decides narrow and wide transformations. Okay, I'll just brief that information. Number of tasks decided based on number of partitions. Okay, one partition, one task. 10 partitions, 10 tasks. Okay, so how number of partitions will be decided? We decided. So number of partitions decided based on size. If data is more than 128 MB, then number of partitions will be created. Okay, 1 GB, so divided by 128 MB, then 8 partitions. 10 GB divided by 128 MB, then 80 partitions. If you have 100 GB divided by 128 MB, 800 partitions. The number of partitions always decided by size of the data, but the number of tasks decided by number of partitions. So 8 partitions means 8 tasks. 80 partitions means 8 tasks, 80 tasks. So keep this in mind. 1 GB means divided by 128 MB, 8 partitions. 8 partitions means it will run as 8 tasks. Similarly, 80 partitions means 80 tasks. 800 partitions means 800 tasks. That's about the tasks. How the number of tasks is decided based on the size of the table, size of the data frame. But how the number of stages? The number of stages will be decided based on transformation type. If it is narrow transformation, then one stage. If it is wide transformation, then 2 stages. Means with shuffle read, so whenever you see Y transformation, go and verify, you can find the shuffle read, shuffle write. This steps will be there. Okay. So I'll show you here in the Spark UI. If you go to the Spark UI, okay, there's a Spark UI. Open this. You can find the job divided into stages. So if you want to know the stages, click on the description link. It will give you the stages. Stages will divide into task. If you go and verify that task information, click on the description link. But the stage level, you can find here shuffle write, shuffle read. Consider now it is not doing any shuffle write, shuffle read. If it's only one stage, this is only one stage. If you have a 2 stages, then you can find this option shuffle read, shuffle write. Okay, let me show you that example. Now both are like whenever we do DF5, DF6, both are narrow transformations. So if you go and verify this one also, one stage. Now let's go and do this another transformation. DF7. Drop duplicates. Let's remove based on employee number. Okay. So anyway, this data frame is created. Let's go and display this. Now if you go and verify the Spark, you see the 2 stages, stage here, stage here. Then go and verify here also Spark UI. So go to the jobs, Spark UI. Under the job, this is the description link. Job divides into stages, right? This is job ID. Go click on the description link, hyperlink. Stage information, 2 stages you see here. And the 2 stages, which you can see the shuffle read, shuffle write. That's why you see the shuffle read here. Then go back and verify the another shuffle write. 2 stages. Stage ID also 121 here. You can go and verify here. This is job ID, which you can see here. (122), 123. Okay. So whenever you see shuffle right, that is a wide transformation. Shuffle right, shuffle read, when you see that. So whenever we see that shuffle read, shuffle right, the same you see here. Right. So this is wide transformation. Drop duplicates is a wide transformation. How to identify? Whenever you see the shuffle right, shuffle read, then that is wide transformation. 2 stages it will go. Technically, more than one stage will call it as stage 1 shuffle right, stage 2 shuffle read. Okay. Narrow transformations, it won't do the shuffling. Only one stage it will go that. Only one stage it will go with that. So this is about wide transformations and narrow transformation identification. Wide transformation, narrow transformation identification. So filter is the transformation for filtering the data, filtering rows. Select is the transformation for selecting a columns or filtering columns. Filtering columns. Then the other transformations are available. Select expression. We'll see that tomorrow. SQL based expressions. Similarly, we'll see other transformation, joins, cross join, repartition, coalesce. So coalesce also another transformation is available. At least we covered most of the transformations. Then we'll see the actions, displaying the data. We already saw that. Then we'll see the writing the data. Means saving the data or displaying the data. So you have 2 types of actions, 2 types of transformations. Narrow and wide transformations, displaying data or saving the data. Write API is an action. Show collect is an action. Show on collect is an action. So this is about the transformations. Still, we're not done all the transformations. So we'll continue from here. Tomorrow we'll understand that. But understand that how Spark is doing a lazy. Lazy means if you are going to do that transformations, means if you are applying transformations, returns another data frame, but job is not executed. Only the job will be executed when you use an action. Means create a data frame, apply transformations. Only if you use the action write API, then only it will read data from source. It will read data from source, write in memory, then write in target. When you use an action. But if you create a data frame, if you apply transformations, only the data frame will be created. It won't read any data until there is an action, then it won't read any data. Only if you use an action. The write API is an action. This is an action. That also we see if you have a tomorrow sometime. Maybe first I'll introduce write API as well. Then different options also available. Partitioning, clustering. That anyway, delta, next week we will see the delta related, okay? First we need to finish the Pyspark transformations. Then write API. The write API is a delta table. What is delta table? That we'll see that, okay? Questions? Okay, good. So if you don't have any questions, we can wind up today. See you tomorrow.
Thank you. Thank you.
See you tomorrow.
Thank you. Hello. Hello.
Yeah, thank you.
Yes, Chaitanya.
Yeah.
It's Nagesh.
Yeah, I will call you,
Yeah.
Ravi. I will call.
Yeah, okay. Yes, Nagesh.
Actually, this transformation CTL and all, it comes in Databricks. No, so here also we have to use the same thing again, or
No, Databricks is not a transformations, but Databricks is IDE, okay? Pyspark only going to process your data. Your Spark is going to help you to apply transformations. So your Pyspark is the language where you are going to do the transformations.
Oh, we are using the Pyspark again in the Fabric. You mean to say that is the reason, or?
Yes, yes. So whatever we are creating a data frame, this is a Pyspark. This is not related to Databricks. This is not related to Fabric. Fabric, Databricks are tools. IDEs are tools where they are using a Spark. Okay.
Okay. Okay. The Spark inside that.
So Databricks is not a Pyspark. Databricks is not a Spark. Databricks is a tool where they are using Spark. Okay. Similarly, or Fabric also.
Okay. Here also we are using Pyspark.
It may be EMR. It may be a Snowflake, Snowspark. Okay. Wherever it is, it may be a GCP data.
Okay.
So wherever it is there, where you can find this Spark and Pyspark. Spark is server, Pyspark is a language. Okay, Python.
Okay.
Yeah, your transformations will be on Pyspark.
Okay. Okay. Thank you.
It's not related to Fabric. It's not related to Databricks or EMR. Those are tools. They are providing you environment as a workspace. Okay, they are providing environment as a workspace, the notebooks and other things.
Okay. Thank you.
Yeah. Okay. Any other questions? Okay, then. See you tomorrow. Thank you.